In today's video, we're going to be talking about how we know light is actually a wave. And so after watching this video, you should be able to give some evidence as to why light is considered a wave, understand how light can undergo diffraction, and distinguish between polarized and unpolarized light. All right, let's get right to it. There's this debate that really probably to this day has not been completely settled. The question is, do you consider light as a wave or as a particle? And basically right now scientists kind of say, well, it's a little bit of both. There's not a clear-cut answer for one or the other. For right now, though, we're going to basically be looking at light as a wave, and some of the arguments for light being a wave is that light reflects, light refracts, light diffracts, light undergoes interference, and light exhibits the Doppler effect. Okay, so all of these pieces of evidence kind of support this wave theory of light. One of the best arguments is that light does undergo interference because some of these other ones aren't as strong as the interference piece. Okay, so keep that in mind. So reflection of light waves, waves are known to undergo reflection, which basically means that it bounces off an object. So if you look in a mirror and see yourself, you've experienced reflection. Okay, so that's a pretty common thing. I think we all know what reflection is. And in this picture here, you can see this kid right here in a Santa suit, and then you can see his reflection in over and over again. This must be a room with two mirrors because his reflection is being reflected off a mirror that's like into the screen and then reflected back into the mirror, so you can see it over and over again. You can see his reflection going down this long, it looks like almost a hall. Refraction of light waves basically says that waves undergo refraction when they change from one medium to another. And if any of you have ever experienced this before of trying to grab a fish in water, or just taking a pencil or a pen and stuck it in a glass of water, you can see here's the pencil in air, and then all of a sudden it seems like the pencil's broken, right, once it enters into the water. And basically it's a change in the speed that causes you to see the pencil a little differently. So that is called refraction, when the path of the light waves have to bend to accommodate that new medium. Diffraction involves a change in direction of the waves as they pass through an opening or around an obstacle in their path. And honestly, we're going to spend a lot more time on diffraction later, so right now this is just a little taste of what it's about. In this picture below, this is a penny. And basically a laser beam is being shot at this penny, and as the laser beam hits the penny, some of these light waves from the laser beam diffract around the edge of the penny. Okay, kind of the same. Another analogy would be like if I hide behind this desk that I'm sitting at right now and I still was talking, could you still hear my voice? And the answer is yes. It's not like because I'm underneath the desk you couldn't hear my voice hitting the microphone. But my sound waves will diffract around the desk. The same thing true is with light waves. It's just not as pronounced, where light waves, when they hit an object, they diffract and they bend a little bit. So if you ever look at a shadow really closely, the edges of the shadow are relatively fuzzy, and you can see that here. This is the image that is displayed on the screen from the penny and the waves from the laser shooting at the penny and diffracting around it. So you can see there's a fuzzy area around the edge of the penny, and we'll talk more about diffraction later. So just right now, just keep in mind that as waves pass through either a small opening, light waves this is, or around an obstacle, their path has to change. It bends a little bit. So let's just talk a little bit about what a light wave is again. A light wave is an electromagnetic wave, okay, and keep in mind there's a lot of stuff in the electromagnetic spectrum. So there is visible light, so the things that our eyes can see, like red, orange, yellow, green, blue, indigo, and violet, are all part of the electromagnetic spectrum, but that's actually just a very small piece. You also have things like radio waves, microwaves, X-rays, infrared, ultraviolet. All of that is all part of the electromagnetic spectrum, and it's all considered a electromagnetic wave. Okay, and an electromagnetic wave is a transverse wave, which is different than a longitudinal wave, because remember, transverse waves, they vibrate up and down or perpendicular to their direction of propagation or travel. Okay? As the name implies, electromagnetic, an electromagnetic wave has an electric and a magnetic component. And so here you can see an electromagnetic wave where you have a magnetic field, which is typically represented by B, and an electric field, which is typically represented by E. And we'll get a little bit more in depth with this later on too. Right now we're just kind of skimming across the surface of this idea of light as an electromagnetic wave. So light, it's kind of difficult to conceptualize. You have to think 3D here. When light is traveling towards you, it's called unpolarized light. And basically what that means is it's vibrating up and down, okay, or traveling up and down like this, but it's traveling up and down in a three-dimensional direction. It's not just traveling up and down vertically, it's traveling side to side, it's traveling at an angle, it's going all directions, okay? So this would be like, it's coming at us right now, that this light wave's coming at us, but it's vibrating this direction, it's vibrating this direction, it's vibrating this direction. So if you kind of think of a slinky going up and down, if you took a slinky and started shaking it up and down, you'd also have to shake it side to side, diagonal both ways, and then that would be kind of what a light wave is. And that's called unpolarized. Okay, a polarized light wave is when the waves of light vibrate only in a single plane. Okay, and there's a couple ways you can polarize light, and that's what we're going to talk about in just a second here. So this top picture here is unpolarized, and this bottom one is polarized light. Okay, because we've removed some of the diagonal planes of light. Now, right now, it's just vibrating up and down, or side to side, or whatever the case may be in terms of how you polarize the light. So let's take a look at ways that you can polarize light. There's something called Polaroid filters, and basically they are made of a special material that's capable of blocking one of the two planes of vibration in an electromagnetic wave. So let's say you have some unpolarized light here, okay, and it travels through this Polaroid filter, which has, if you will, a slot that only allows the vertical plane of light to travel through it. Okay, so after the light goes through this Polaroid, all you are left with is the vertical up and down motion of light, and this is called polarized light. Okay, and so this is one way that actually sunglasses work, and we'll talk a little bit more about it in the next slide. Right? But this is called polarization by a filter. Basically, this filter filters some of the directions in which the light wave vibrates, and it leaves you with just like one or two. Now, what's kind of interesting is, let's say after this light wave comes through, and you've got this vertical one, let's say I put a Polaroid filter here that only allows the horizontal light waves to travel through. Well, do I have any horizontal light waves here left? The answer is no. So what would come through this Polaroid filter? Nothing, right? No light would be able to travel through it because you're blocking the vertical direction, and now I'm blocking the horizontal direction. There's nothing left for light to travel through. Unpolarized light, such as like sunlight, sunlight can undergo polarization by reflection off of non-metallic surfaces. So like roads, snowfields, water reflect light, and there's a larger concentration of vibrations in the plane parallel to the reflecting surface. Okay, and that sounds kind of complex, but bear with me here. If this is the sun, and I draw the sun here, it's supposed to be a sun. The sun's always happy, it seems like. This is the sun, and it's shining light, and it's hitting, we'll say, I'm going to put a boat here. We'll say this is water, okay? So the sun, it's shining its light. This is all unpolarized light. It hits the water, and the majority of the reflected light is polarized into the horizontal direction, okay? You can see that it's all polarized in the horizontal direction. If I'm a boater and I'm sitting here and I'm looking at this light being reflected off of the lake, the majority of the light hitting my eyes and making it difficult to like see down into the water is this horizontally reflected light. And so one thing that, like fishermen in particular, they will buy special sunglasses that are polarized basically to block this light that's reflecting off of the lake. And so it makes it much easier to see the lake with those sunglasses on. So the sunglasses, if we take a look at the Polaroid filter, basically what it would look like is there would be a slot for only vertical light to travel through. So what does this do? Well, this blocks all of that horizontal light that's reflecting off of the lake and making it much easier for the fisherman on his eyes. Okay, so that takes care of this lesson. I will see you guys next time.